Alright, good afternoon and or morning. Here's the review for the test. Okay, so here's what's going to happen. Molar mass problems, they're real simple. You take the molar mass of these compounds, or of these individual elements, you add them together. So it's 35.45, and that's going to equal, let's see, what did I write on there? 58.44. The units are going to be grams per mole. Alright, Na2SO3, same deal here, okay? You do 2 times 22.99 plus 32.07 plus 3 times 16. You add it up, you get 126.05. Right, so self-explanatory. Move on to the next part. I'm only going to answer a couple questions because I want to save most of the video for the harder questions. So let's look at these two guys right here. Okay, so with this problem right here, what we have going on is we're going from moles to grams. Now what distinguishes this type of problem from these problems right here is you're going from moles to moles of something else. Okay, you start off in NaCl, you end in Cl2. But with the problem that we're working on right now, we're starting in moles of NaI and we're ending in grams of NaI. So we do moles of NaI, and it's just a simple mole conversion. So we multiply by the molar mass, and then we divide by 1 mole. And the molar mass of NaI is 149.89, and so this is 4.32. So all it is, and that's just 1 right there. You just multiply through, and that gives you exactly 648 grams. 48 grams, because we start with 3 sig figs. So it's 648 grams NaI. Now notice it's not grams per mole because the moles got crossed out. Okay? So same type of problem here. We're starting with formula units, ending in grams. So what we're doing is we're taking this one step further. This time we do 4.32 times 10 to the 23rd. We do 6.02 on bottom times 10 to the 23rd. Do 1 mole on top, 1 mole, and then 149.89. Okay, and so you end up getting, if I remember correctly, 107.6 grams. So we'd run that to 108 grams NaI. Alright, now let's do one quick thing right here. You need to remember that if you're going into moles, you're going to divide. Okay, if you're going into moles, you need to divide. If you're going out of moles, you need to multiply. Okay, so we saw that in our last problem right here. We went into moles first, so we divided by 6.02, and then we got out of moles, so we multiplied by the molar mass. Okay, so that's those types of problems, just molar conversions. So let's talk about one problem of a mole to mole ratio. And because it didn't want to copy correctly, we're going to do this one right here. So we start with moles of H2, moles of H2O. So what we do is we always put what we're starting with in the top left corner. So that's moles H2, and it's 2.32 moles H2. You put 2 mole H2 on bottom and 2 mole H2O on top, because this is what we're starting with and that's what we're ending with. This is a mole to mole ratio, so we put our coefficients there. So this ends up being the same of 2.32 mole H2O, and that's what it is for all those problems. Okay? Now let's move on to stoichiometry. Woohoo! Huzzah! All that jazz. Excuse me. Alright, so we're starting with grams of O2 and we want to end in grams of H2O. So this is what we do. So we start with grams of O2. We need to get out of grams of O2 and go to moles of O2. Get out of moles of O2 and go to moles of H2O. Get out of moles of H2O and get into grams of H2O. Here's the molar mass. Anytime that it's grams in this equation's in here, and it's not in this part right here, anytime it's grams, you're always going to put it over or under 1 mole. So that's what we get right here. Again, this right here is the molar mass, and in here, these are the coefficients. So this is a 4, and that's a 5. So it's 68.3 grams O2. Okay, so multiply it through, divide by the bottom, and you will end up getting, let's see, you will end up getting 30.8 grams H2O. That's it. Okay, those are real simple problems. Now, what you're going to do for limiting reagent and percent yield. All right, with percent yield, what you want to do is do a gram-to-gram problem. Now, you're going to do a gram-to-gram problem. We're looking at percent yield, a gram-to-gram problem, grams of this and grams of that. The reason why, so we start with grams of this, and it wants another percent yield of K3PO4. So you do a gram-to-gram problem of H3PO4 to K3PO4. We just did one, so you should be able to do one yourself. Whenever you do that gram-to-gram problem, you end up getting 192 grams of K3PO4. So what you do is you, now with percent yield, excuse me, it's actual divided by theoretical times 100%. Our actual yield is 89.0 grams K3PO4. And we know that because it tells us that in the problem right here. So we divide by 192 grams K3PO4 because that's our theoretical problem that we got from our gram-to-gram calculation. So when we multiply and divide, we get 46%. That's good enough for government work. Okay? That's how you do percent yield. All right, last but not least, that brings up the rear of limiting reagent. Okay, with these problems, again, it's going to be a gram-to-gram problem.
Where's the sheet, Mr. Ford?
Okay, so the last problem is going to be limiting reagent. So what you're going to do for this one is we set it up by saying, if we have 12 grams of ammonia, and that's the only thing we had, and let's say that that was the limiting reagent, what would the answer be? Excuse me, how many grams of water would be formed? Okay, because that's what we're looking for right here. So again, we do one of those great gram-to-gram problems from grams of NH3 to grams of H2O, and it's a 3-step problem. Okay, so you get molar mass here, 1 mole, coefficient mole of H2, 1 mole of H2, molar mass of H2. And if you do that, you end up getting and making 19.0 grams of H2O. So we do the same thing for 14.0 grams of O2. So again, 1, 2, 3 grams of H2O. So you do molar mass, 1 mole, molar coefficient of O2, molar coefficient of H2O, 1 mole H2O, grams of H2O, and you end up making 9.45 grams of H2O. Now, the way this works is if we said that we didn't care about the oxygen, so let's say the oxygen was in excess. If that's the case, NH3, we'd only be able to produce 19 grams of water. But with oxygen, let's say that this was in excess. And so if that's the case, we're only able to make 9.45 grams of H2O. That's the limiting reagent. And the reason why that one is a limiting reagent is because we can only make that many grams of water if we start with that many grams of oxygen. So the answer is going to be the following. Our limiting reagent is 14 grams O2. The excess is ammonia, and the grams produced is that right there, 9.45 grams of H2O. Alright, so that's it for those. Make sure that you go ahead and finish the review for your extra credit tomorrow. Alright, hope you enjoyed.